Şimdi kaydetmeye başladık. So let's start with this is math. Why I cannot write? Why not? Okay. Math 260, section 3, right? Section 3. So let's start with. So what will what will we do in this lecture? In this class? The basic. We have the outline of this lecture, the outline of the course, the syllabus on the. You can see on the class. So today we will start with matrices. So matrices will be important for linear algebra, and later we will see the solving linear equations, systems of linear equations. So the matrices will be used there. Okay. For this, what's a matrix? What's a matrix? Well, so you may think it as like this, as you see. Either you can use this notation, for example, something like this, or some people uses, let's say, it doesn't matter which notation you use, but the list of some numbers. These numbers might be either real numbers or complex numbers or anything else. But for us, it will be always complex numbers, real numbers, sorry. So for this, let F be a field. Field, which is either real numbers or complex numbers, nothing else. We will see formally, we will see a matrix as a function. Formally, a matrix, an M cross N matrix, which we will denote by A over the field F, is a function. Like this. You take the set from all these numbers ij, such that these are the natural numbers. I is from 1 through n, m, and j is from 1 through n. From this set into field. So it's a function, just like it's a function. And so we denote this function aij as aij, or sometimes little aij, and we write the function this way. And we write it like this. Formally, as we said, it's a function. So a11, a12, a1n, a21, a22, a2n, and etc. am1, am2, amn. So the function takes 1, 1 to this first entry, a11, whatever that is. I will give examples. For example, if you put, let's say, -1, 2, square root of 3, pi 1 4, for example, then this is a function from ij, where I is from 1 through 2, and j is from 1 to 3, so that a11 is, which is namely a11, the image of a11 is -1, a12 is 2, a13 is 1, etc. Let's write a21 is square root of 3, a22 is pi, this is pi, and a23 is 4. So these are matrices. So we just denote the function as an array like this. Okay, this is, or we may have another example, or we may have something, a function like this only, 1, 2, let's say 5, 4, for example, so that it is so that a11 it has only one row. A11 is 1, a12 is 2, etc. This is a13, this is a14. Okay, and this is this A is 1 cross n matrix. N is 4. Sorry, 1 cross 4 matrix. And in the above example, this is 2 cross 3 matrix. Okay. Okay, these are matrices. Next, when you have a matrix, A11, A1n, A21, A2n as above, and AM1, AMN, so that this is let's see, let's use different colors. So this is the first row, row 1. This is row 2. This is row M, exactly M rows. And there's also columns. Let me use different. So these numbers are the first column, and etc. And this is the last column, so the nth column. So when you write M cross N matrix, so this M represents the number of rows, and this N represents number of columns. Always. Okay. So when you have, if M is equal to N, then we say that A is a square matrix. M is a square matrix. Okay. And in this case, A is like this, A11, A12, A1n, A21, A22, A2n. So these are the terms, like terminology that we should fix first, because we will use it all the time. This is A2 and AN2, ANN. And these entries, this entries are called the main diagonal. These are main diagonal. There's also other diagonal like this, but we will usually interest in this main diagonal. Okay. This is an N cross N matrix. Well, for it's a little bit, sometimes it is confusing what's a natural number. For us, natural numbers will be the integers, n. So I will denote by n. It starts from 1, 2, 3. It starts from 1. So for convention, let's say 0 is not included here. It's just a matter of definition. It doesn't matter 0 is a natural number or not. We are not in the philosophy of this. So let's set up this notation. And there's an important notion which is the Kronecker delta. Kronecker delta is a famous mathematician who lived at the end of 1800s, and that's the function from natural numbers to cross natural numbers into the 0, 1, and that is defined as delta takes ij to 1 if I is equal to j, and 0 otherwise if I is not equal to j. So for example, what is delta 1, 5? That's 0 because they are 1 and 5 are different, but delta 2, 2 is 1 because they are the same. Okay, and the identity matrices. Oh, there are more people are coming, but unfortunately we cannot accept them. Okay, the identity matrix is I, which is the n cross n matrix. Sorry. Is the n cross n matrix I such that this ij is equal to delta ij. So that the I is or sometimes we denote in, either I or in. They are both fine. This n denotes the size of the matrix, n cross n matrix. It is this matrix 1, 0, 0, 0. So the first along the main diagonal it is 1. The rest is 0. Yes, this is a square matrix, n cross n matrix. Let me write like this: n cross n matrix, and the main diagonal is 1. The rest is 0. How about the equality of two matrices? Equality of two matrices. So, by the way, let me say before this, let f m cross n. This f is the field, as we said. Usually, it's real numbers. This is the set of all M cross N matrices instead of all M cross N matrices. And so namely, these are all functions from all functions into F from the set we just defined above, and two matrices in the same size, two matrices of the same size are equal, then A is equal to B if and only if each of the corresponding Aij is equal to Bij for all ij in the domain, of course, in the domain of the function. So, for example, let's say A1, 2, 3, 0, sorry. And if this is equal to, let's say 5, oops. 5, 2, oops, not 2. This should be 1. 1, 2, 0. Then A must be 5. Okay, we will have only 10 more minutes, and then after that, we will be done for today. As I said, I will put this on the on YouTube channel, and I will let you know. I will send you an email, and transpose also. Transpose. So if you have a matrix, M cross N matrix, then it is transpose AT is an N cross M matrix such that AT, its value at the point Jij is Aji, namely ijth entry of the transpose matrix is the jith entry of the original matrix. Okay, let's see some example. So if A is, let's say, 21, 5, 0, 2, then its transpose is 21, 0, 5, 2. So you make columns as rows, and rows are column. If you have another matrix, for example, let's say 1, 2, 2, 1. Yeah, then its transpose is like this: 1, 2, 2, 1. Okay. So there's only one row, and in the transpose there's only one column. Okay, that's transpose. And next. Matrix addition. Let's start with the addition of matrices. So if we have two matrices of the same size, let's start with an example. So if A is, let's say, 2, 1, 3, 4, and B is -1, 2, 3, 3, let's say, then A plus B is, let's start with an example, and then I will give the formal definition. You just add the corresponding entries. So 2 plus -1 is +1. 1 plus 2 is 3. 3 plus 3 is 6. 4 plus 3 is 7. And the formula is for a given for a given A and B in the if we have two matrices of the same size, then their sum A plus B is the matrix such that its ijth entry is a ij plus bij. Then, so namely, more precisely, A plus B is the matrix given by this equality. Okay, and there is also zero matrix. Zero matrix is the all entries are 0. All matrices are or all entries are 0, and if you add, so you can check these properties. A plus B is the same thing as B plus A, so it is commutative. The reason is that our field is always commutative, and when you are adding 3 matrices, usually you cannot add 3 of them. We know how to add 2 of them, but in order to add 3 of them, so first you can add B to C and then to A is the same thing as A plus B plus C, so that you don't need to write parentheses. So when it is this associative, you don't need to write parentheses once again. And for the zero matrix, A plus 0 is always 0. This is okay. This is 0 plus A is always A for all A. And when you can add, so for a given, let's say minus A ij, suppose it is defined as minus A ij. In this case, A plus minus A is 0. So A plus minus A, that represents the matrix A and the matrix minus A. For example, if A is 2, 1, 3, 4, let's say 0, 0, then minus A is minus 2, minus 1, 0, minus 3, minus 4, 0. Okay, that's minus A. The negative of A. Okay, so we will not prove these statements. You can prove them easily. For example, the first one starts. You just Aij plus Bij is the ijth entry of this matrix. The first matrix is the same thing as Bij plus Aij. It follows from this equality. Okay. Also, you can look at the book by Jamal Koch, our lecture textbook, basically linear algebra. You can study it also from there. Okay. There's also scalar multiplication. So what's a scalar? Notation is a scalar is the element of elements of the field F. So for example, F is a real number, elements of just real numbers or complex numbers, depending on your field at your hand. So scalar multiplication is so given an M cross N matrix, and at the point an element, a scalar C from the field, then C times A is the matrix whose ijth entry is C times Aij. So the right